park. So you need listed building consent to dig a trench. Well, by then we'd drained this, and the conservation officer got frightfully excited and said, you should have had permission to do this. I said, no, it's maintenance. And I said, anyway, we don't have greater crested newts, because that's all mown. All that is mown down to the edge. And greater crested newts need nice, lush meadows. They don't like mown areas. So the conservation officer was firmly put back in their place. So, in come the diggers. Well, you can see the sort of silt level here. Pretty deep, not very nice, but it needed cleaning out. And once it was cleaned out, we also discovered a nice bund here, which was actually on the old 17th century plans. That suited us down to the ground, because that would contain the silt in future years to come. But anyway, so we took out about 3-4 foot of water, something like that, of silt, and then we laid 60 100-meter coils. These then were fed back into the manifold chamber, which we had to build, and we dug the trench up the top. Now, planners said, yes, but you must have an archaeological watching brief. And when I approached the ones they recommended, they said, oh, we can't do anything for 6 months. Luckily, a little card had arrived on my desk a couple of days before that from a man who'd actually split from one of these groups and was looking for business. He said, I can start next week when you dig the trench. So that was very appropriate. And he got frightfully excited about something that I still don't understand, which was a huge 17th century drain. Or, no, 15th century was it, or something? Neil, can you remember? Anyway, can you remember what it was?
It was big blocks of stone, but beyond that, I'm sure.
Yeah, well, anyway, we didn't understand it. So, moving on, this is the manifold chamber where all the pipes come into, and then they're separated into 2 pipes. So you'll probably say, why are there 4 pipes in there? We put 2 extra in for when we enlarge the system. These are extra. So, but the 2 big pipes are the main ones coming up to the house. As I said, we had an archaeological watching brief, but we also knew in 75, 76, when we had the drought, brown areas appeared on the lawn that showed that these foundations had been laid, or even the walls had been built. We weren't quite sure which. We knew that we were going to hit this if it existed, because that's where we were headed for. Sure enough, we did. We hit the wall. And we didn't realize how it had been built or how big it had been. And it was actually the most beautifully worked stone. Well, the archaeologist said, right, I want to take pictures, I want you to preserve the stone, now go through it. So we took it out. We continued, sorry about that, and we had to go through this wall here, underground. Now, English Heritage said, no problem, de minimis, we don't need to watch, keep an eye on doing this, so you can do it. So along comes our friend the digger, digs up the lawn, and the boys go through the wall. This was the other side, where we had this area. The top of the wall is there, somewhere. We had to come through about here. Here we have George going through the wall, and the pipes coming through. And that's afterwards. That's afterwards, and so is that. Right, we come through the wall, still got our 4 pipes. Now, I'm driving around the Périphérique in Paris. We've had sunshine like this for 2 months while all this work's going on. I get a call. We've got a slight problem. So what's that? So we know the trench and the pipes. I said, yes. Well, we've had torrential rain. We've got a river running down to the lake. I said, so? Yeah, slight problem. It shrunk the pipes by 6 inches. The whole length had all been welded together, effectively. We need an expansion loop. And that's what this is. This was put in on the back of... Oh, it's now not working. This is actually on the back of the wall down there. But you'll see that later. So this, effectively, whenever you get any contractions or expansion of the pipework, this allows for it. This is it going into the boiler house. And these are the old boilers. This is what we're replacing, effectively. This big one on the right here still exists, but those two had to go. This is the new boiler room, all in this wing underneath. That's what it looked like before. And these are the things that really cost the money. Carbon steel. Beautiful. Absolutely lovely to look at. Anyway, the boys arrived, and the first thing they did, before we even started with the coils, was actually erect all the stuff in the new boiler room. And this is it before we put all the insulation on it. And that was an extremely extremely well done job, because I think they took only about 3 or 4 weeks to do it. Our electrician was involved in helping them do it, and our plumber. Now, it was a leap of faith going with anybody to do this, because it was new technology in a very large building. Nobody had done anything like it before in a historic building. So there were 1 or 2 minor problems, but between Ecovision and ourselves, we sorted them out. They related to overruns on the electrician's time and the plumber's time. I'm being honest with you, but it is important to remember that your electrician and your plumber will be heavily involved because they know the building. Sorry? So there we have the boiler room, and these are the 2 heat pumps, and those are the 4 buffer tanks. 2 of them deal with the hot water, and 2 of them deal with the domestic hot water, and 2 of them deal with the heating. That is how this is the only remaining boiler we have. Remember those 2 orange ones? They were behind here. That still exists, still works. We've only had to use it once during the time since the heat pumps were installed, because we have a massive, we think it was a massive electricity surge that wiped out the control panels on both the heat pumps. Now, to this day, we still haven't worked out what happened, but we had to run this for 12 days. The expense of that was phenomenal, because it was in the middle of the really bad winter, not this winter, but the winter before. And I'll show you some figures afterwards. The long and short of it is, thank God we don't have to use that. It doesn't smell anymore. We don't have delivery lorries, with oil tanks which are spilling oil, driving over lawns. And we don't have the breakdowns. And that, to me, is the most amazing thing. We don't have any maintenance on the heat pumps. They just sit there and they churn away happily. But this is going back to, now we're going to start talking figures. 170,000 total cost. Bit more because we did a bit of extra dredging in one of the ponds. We got 10,000 grant from the ARNB's Sustainable Development Fund. That's the Howardian Hills Area of Outstanding Natural Beauty. Hell of a mouthful, but anyway, we got £10,000 from them, and they insisted that we put up some form of display. Well, you'll see that later. We had a very short time window, and we just saw that with the figures, that kind of thing made sense. And the nearly 60,000 interest-free loan repayable over 3 years also helped that. We initially looked at a payback of about 8 years. When I put this together, it's about 6 years. We're looking at less than that now. This is the panel that we had to put up, which you'll see later. That has a description of what ground source heat is, why we changed, how we did it, and the timings and the costs. It also has an up-to-date panel which shows you the savings we've made, as well as a real-time thing showing carbon savings, electricity used, and I can't remember the other item. We'll get that. But these are the cost comparisons. 2008, entirely oil. That's just hot water, oil. 2009, oil, just hot water and oil, and then we move into ground source heat. Well, I think you'll see from those figures that, and I'll show you some more in a minute, but the cost savings are huge compared to when we were running the oil. And these are the percentages. The heating and hot water percentage of total oil and electricity costs in 2008 represented 60.52%. 2009, with part of the year being run by the ground source heat, it dropped to 28.89%. Last year, 24.73%. This year, that figure is high because we haven't gone through